good morning or afternoon or whatever the case might be. Um, this is a preview of the exam for Friday, and I'm going to go over the practice exam a little bit very briefly with you. I'd like you to bring that practice exam with you to class or have it ready for class on Monday, and we'll talk about problems that you have or that you see or that you want worked out on this exam. Um, Tomorrow night, Emily's running a Zoom review session where she'll also go over that exam. And I think that's at 7 o'clock. So let's take a look. I'll put up the exam here, the practice exam. There she be, and this is how it'll look. When you see the exam, it'll be written out. It'll have a pledge and your name, a little directions saying that you can use Wolfram Alpha or Mathematica on any of these problems, and how to submit the exam on the submission portal on Moodle. For this first page, at the end of the exam, you can sign the pledge and scan it and submit that as a PDF on the portal. So let's take a little look at the problems, first of all. Problem 1 is definitions. And these are not the most general definitions, but pretty general. So I would like these written out and I'd like them correct. You won't have anywhere near this many on the actual exam. So this is sort of a comprehensive group. But what does it mean for a vector to be a linear combination of 3 vectors, v1, v2, v3, that I give you? And so I would like you to write out that definition, something like it means there are numbers, S1, S2, and S3, so that U equals S1 times V1 plus S2 times V2 plus S3 times V3. Linear combination. What does it mean that that set of vectors is linearly independent? There are 2 definitions for that. One is that no one of them is a linear combination of the others. And the other one is that if you solve the equation x1, v1, x2, v2, and so on equal to 0, the only solution to that is the 0 solution. And so on. What does it mean to be in the span? It means that a vector is in the span means that it's a linear combination of those vectors. Now, with 1 and 3, if you write that in number 1, what does it mean for U to be a linear combination? It means that U is in the span. That is correct. But then you can't use the term linear combination in number 3 to define span. It's sort of circular. So you want to be a little careful of that. These are the 3 elementary row operations. I'd like them written out. And so on. So there's a group of definitions here, or very short answers. Number 10, for example, give you a linear transformation, and I give you what happens to 1, 0 and what happens to 0, 1. Then the matrix consists of these vectors 2, 1, and 3, 4 in the columns. So that's a fact that's important, but it's easy, and I'd like you to know it, and I'll probably ask this. Okay, after the definitions, we get into some of the meatier part of the course. Solving the systems of linear equations. I will give you a system such as this. It won't just be a 2x2, or, I mean, I would have no problem giving a 4x4 on the exam since you've got Mathematica. And I'll first ask for the augmented coefficient matrix. I could ask for just the coefficient matrix. So in that case, I want to know, what is that matrix? Now, you can give your answer in Mathematica if you want, or you can write it down and scan this thing. What is the reduced row echelon form? And I expect to use Mathematica on that. What is the solution? of this system of equations, if there is one. So if it's unique, then the solution will just be a particular point. If it's not unique, you'll have a free variable to deal with, and so on. What is the geometry of the solution? Okay, if it's unique, then it's a point. If it's got one free variable, it'll be a line. If it's got two free variables, it'll be a plane, and so on. And it resides in this case, it resides in four-dimensional space because you've got four variables, x1, x2, x3, x4. So we'll go over the details of this on Monday, actually get these solutions. Problem 3 is not unusual for a Humke exam. So it's got a little story. I've had students in the past say that this is just smoke, and in a way it's not exactly smoke, but it's a little story. But the real problem is that I want you to solve one of two types of applied problems. On the actual exam, I won't give them off from the book. I'll have a couple problems there. But here are the problems in the book. Traffic flow, temperature equilibria, chemical equation balancing. So I will give you two problems and ask you to do one. So if you do both of them, I will grade them both and give you your best score. Problem 4. Now we're going to check some of the stuff about linear independence and combinations and so on. So I give you a set S of vectors. Is this a linear independent set? Why or why not? So I expect you to use Mathematica on this, and you can put these vectors in columns of a matrix, row reduce that matrix, and if there is a pivot in every column, then it's a linearly independent set. If one of the columns does not have a pivot, then it's not a linearly independent set. So row reduction will answer this. You want to remember to put those vectors in the columns of a matrix, not a row, because you're really solving equations. In number 2, is this in the span of S? So this is a series of equations. Now you want to set up the augmented coefficient matrix. So again, the vectors from S are the first vertical vectors in the matrix, and then that's augmented with the vectors 0, 1, 0, 0, row reduce, and you should be able to read off if that is in the span or not. If it has a solution, then it's in the span. If it doesn't, it's not. So problem 3 is to make sure you understand the relationship between these coefficient matrices that we have, the variable vectors, x1, x2, x3, and systems of equations. So I give you A, I give you the vector x, and I give you the equation ax equals 1 minus 2 minus 1. What is the system of equations that refers to? So problem 5, here I give you a linear transformation. I ask for the domain. And for the domain, you look at the x's. There are 4 of them. So this domain is R4. The codomain, I don't know if I asked for the codomain. I should have. So the codomain will be R, and let's see, there's the first y, the second y value, the third y value, and the fourth y value. So the codomain is also R4. What is the matrix representing L? So I want you to be able to write this in matrix form. Matrix representation. And then I want to know if 1, 2, minus 1, 3 is in the range. Why or why not? So when you're doing that, you really want to know, is 1, 2, minus 1, 3 in the span of the vectors in your matrix you just found? So this is again solving looking at an augmented coefficient matrix where the coefficient matrix consists of the matrix representing L that you just found, and you augment it with this 1, 2, minus 1, 3, and see if there's a solution or not. If there is a solution, it's in the range. If there is no solution, then it's not in the range. And I think this is the final problem. Here I give you a linear transformation from 3 space to 3 space. And you know what happens to the first 3 vectors, 1, 0, 0, 0, 1, 0, 0, 0, 1. What is T11? So these are problems like in section 3.1. 1, 1, 1 is just the sum of the 3 vectors from the domain that I gave you in the directions, 1, 0, 0, 0, 1, 0, 0, 0, 1. So if you add up those 3 vectors, this one here, this one here, and this one here, then you get 1, 1, 1. Since it's a linear transformation, T of 1, 1, 1 will be the sum of the 3 range vectors I gave you, 3, 2, minus 1, minus 1, minus 4, 2, and 1, minus 6, 3. Another way to do this is to find the matrix representing T and just multiply by 1, 1, 1. We'll take a look tomorrow. And here I ask for that matrix representing T. The matrix representing it is just these 3 particular vectors in the columns. Now, what is the equation of T? So to find the equation, you have to multiply that matrix times x1, x2, x3, the vector, just as in problem 2 times ago. And then that will give you the equation for T. The domain and codomain. The domain is R3 and the codomain is also R3. Probably on the exam I'll have those different, but both codomain and domain are 3-dimensional space. What is the range? What is the range? So now the idea is to find explicitly a formula for the range. Is it a plane? Is it a all of 3-dimensional space? Is it a line? What is it actually? Is T 1 to 1? So when you reduce the coefficient matrix, if there is, since this is 3 space to 3 space, then that unifying theorem holds. And if it's 1 to 1, it's 1 to 1 when and only when there's a pivot in every column. Is it onto? Since it's 3 dimensions, 3 space to 3 space, it will be 1 to 1 when and only when it's onto. So again, if there's a pivot in every column, or in this case, in every row, they are the same, then it would be onto. And to see whether 2, 3, 1 is in the range, you have to augment that coefficient matrix, the matrix representation. You have to augment that with 2, 3, 1, row reduce, see if there's a solution. If there is a solution, then it is in the range. If there is no solution, it is not in the range. So that's it. And we will talk about this on Monday. Have a go at this before Monday so that you know what's giving you grief. Because on Monday, I'd like you to be able to ask questions in that problem with the problem session. Okay? Hope this didn't spoil your weekend, though. So have a good weekend. See you Monday.